Okay, I think this is the first live podcast on YouTube from this channel. Okay, let's wait. We will check whether it will going on live. I think yeah, it's on live. I want to check whether my voice is correct or not. Okay, testing. Yeah, it's fine. Okay, this video what we are going to dive into is um, one of the one of the um, mm, one of the data mining software we called WEKA, which they have machine learning algorithms and we can use those without coding. So this is a no code platform. So I decided to watch a YouTube playlist and we will study WEKA through those playlists. Man. Okay, I will show.
Want to build a machine learning model without having to code? If you ask,
I want to share my screen. Okay. Here, this. Oh, sorry. This is the WEKA software. We will go through that one. And this is the playlist I'm going to watch. They have almost 8 videos, each are around 15 minutes. So it will take. I think, if I continuously did this, I can complete within 2 hours. Now the time is 1:50 a.m. Yes, 1:50 a.m. midnight. I like to complete before 4 a.m. So we will watch each videos and we will try using WEKA. First I will set up like this one. So we will watch videos in this side. Okay, I will put it in this side. Okay, I will make this side. Okay, my video's in. Yeah, I think it's fine. Okay. This is the first time I'm doing live. So please give me a feedback. That's important for me to grow. Okay, we will see. Sorry. I think this one is fine. I want to set up again now. Okay, when I'm doing if the layout is problem, I will rearrange that. Okay, first we will see this video. I want to check whether my audio is streaming. Okay, this is the first video.
if you answered yes, then this video is for you because today I'm going to be showing you a very simple machine learning software.
Okay, the audio is streaming. Now I'm going to watch all these videos. Whether I don't know I will get copyright or not. I think it will not give copyright for this one because I am reacting and also I am doing things. So I think I will not get the copyright. So I will try to complete all these videos. So I will speed up the video and also we will do the things.
Which will allow you to build a machine learning model using a simple point and click. And so without further ado, we're starting right now. So the software that we're going to be using today is called WEKA, W-E-K-A. So let's Google it for that. W-E-K-A. And it's the first link here, WEKA 3, data mining with open source machine learning. So this software is built in or coded in Java, and it's going to be a point and click software. So we could just simply download it by clicking on the download.
Java,
and for those of you who are interested, it will also allow you to use the scikit-learn and also R and also deep learning 4J. And so I'll probably be covering this in a future video, but for this video, I'm going to be showing you how you could build a very simple machine learning model using WEKA. So first thing that you want to do is click on the download. And then depending on which operating system you are using, you're going to download one of these files.
Oh man, this is, they have a Linux version also. It's okay.
And then you're going to be installing it onto your own local computer. Okay, so pause the video for a moment while you download and install it.
Download and install.
Okay, and so now that you have already installed WEKA, let's open up WEKA.
Let's open up WEKA. WEKA. This one has been just done now.
Okay, so this is the WEKA, and it's called WEKA GUI Chooser. So the one that we're going to be using is the Explorer. So you want to click on this one.
Okay.
So WEKA stands for Waikato Environment for Knowledge Analysis, and coincidentally, WEKA is also the name of this bird found in New Zealand, and the software is developed by the University of Waikato. And so a point to notice that this software was the first machine learning software that I personally used in my early days venturing into machine learning and data science. And so it was back in 2005. And so at the time, all of this is pretty much known as data mining. And this was my favorite tool whereby I have been using it for several years in developing my early machine learning models. And so I could use neural network, support vector machine, decision tree, random forest. And in this video, I'll be showing you how you could build a simple model. And so let's get familiar with the general GUI interface here. So you're going to see that there are a total of 6 tabs here. And at default, it's going to be at the preprocess tab. And here, you're going to be able to import your data, open file. Okay. So let me first find a data set for you to play around with. So why don't you click on open file?
Okay, I will check that. Okay, this one is that menu he is using. They have a default data sets. I already explore those things. I will show. There is a menu somewhere. WEKA Audio City. I think it's on the place where I installed the WEKA. Okay, here.
And then you're going to navigate this to the program files.
Yeah.
And you're going to find the WEKA 3-8 folder. And then you're going to click on the data folder. So in this folder, there's click on
1.5 is more speed. Okay, we will. I go data. Okay, where is CPU data? Okay, I open the CPU data. Okay, the same data.
And so right here, you're going to be seeing.
Why it's not visible in OBS? Why it's not showing in OBS? No. It's opening another window, I think. Okay, it's fine. We will study this one.
That this area is going to be telling you the general features of the data set. So here you're going to see that instances is 209, meaning that there are a total of 209 rows or 209 data samples. And there are 7 attributes. So these are the columns. So there are 7 independent variables. So I mean, there are 7 variables, and the 7 variables are shown below here, where the first 6 variables are the independent variables, and the 7th variable is the dependent variable, or the class variable. So you're going to be making use of the 6 independent variables here in order to predict the dependent variable, or the class variable. So on the right-hand side here, you're going to see the general attributes of each of the variables. So for variable number 7, you're going to see that the minimum value is 6, the maximum value is 1,150, the mean value is 105.62, with a standard deviation of 160.831. And if you click on each of of the variables here, you're going to be seeing that the minimum, maximum, mean, and standard deviation value are changing. And normally, in order to build a model, like a regression model or a classification model, we will be needing to do some data scaling, because you're going to see here that each variable has different minimum and maximum value, or even different mean and standard deviation. And so this...
Yeah, in previous video also we saw those things. When we want to what we call when we want to model the model, we want to scale this to, usually we will scale around 0 to 1 like that. In here the range is different. We can see the maximum range is here. Minimum is 64, maximum is 32,000. Yes, 32,000 like that. This one is the Y class, like that, the predicting class. These are the factors depending on how we want to predict. Okay, that's what
this will be problematic for the building of the model. And so what we need to do is we need to perform a data scaling approach, whereby we're making each of the independent variable to be in a similar scale. So you're going to see here that the minimum and maximum values for all of them are different. So upon doing a min-max normalization, you're going to be scaling the minimum values to be 0 for all of the 6 variables here, and the maximum value will be 1. So let me show you how to do that. So in the filter, you're going to be clicking on the choose, all right, and double click on filter. Click on the triangle here, find the unsupervised, find the attribute, and then find...
Here we are choose, filters, supervised, attributes. Am I correct? Unsupervised. Here we go. I will check.
To be 0 for all of the 6 variables here, and the maximum value will be 1. So let me show you how to do that. So in the filter, you're going to be clicking on the choose, all right, and double click on filter. Click on the triangle here, find the unsupervised, find the attribute, and then find...
Okay, is that unsupervised? Okay, unsupervised attributes. They have many functions. When we go to the mouse, we can see what are those things. The new attribute will contain all missing values. The new attribute will contain all the missing values. Here what we are going to do is we are going to scale. Where is that man? Well, storing time series delta. Okay, I will see.
Normalize. Okay, and then you want to click on normalize.
Oh, normalize. We did all these things using Python. Now we are going to use WEKA. This one is no code. Where is normalization? Normalization. Okay, here is normalization. Okay, here it's telling what is normalization. Also, by default, the resulting values are in the range. Is it appear in the OBS? I have no idea. We will see. It's not showing in OBS, but when I move the mouse, it will give a box and there is a description about how it works. So by default the result values are in 0 to 1. The data used to compute the normalization interval, but with the scale and translation parameters, one can be changed to example with a scale to. Okay, we can change the scale, those things. Okay, selected, it will appear here as normalize,
and then you want to click on apply. And so after clicking on apply, you're going to be seeing that each of the 6 variables here all have a minimum and maximum value of 0 and 1. So all of the...
Okay, here the minimum and maximum is 0 to 1. Okay, now I'm going to scaling is around 1. Okay, now then I will apply and we will check. Okay, now each and every data is minimum is 0, maximum is, which means it will scale to 0 to 1 like that. We did all these things using Python. Now we are using no code things.
All of them are now comparable. Okay, so all of them have a minimum and maximum of 0 and 1. So all 6 are now comparable. And make note that only the class variable was not subjected to any type of min-max normalization because this is the value that we're going to be predicting. So we're not modifying it in any way. All right. And so now we're ready to build a model. As you can see, this is fairly simple. You just click on the open file in order to import the data in. And then you could click on the choose in the filter. And then you click on the normalize function, click on apply. And then you have essentially done min-max normalization. And so when you're clicking on each of these variable, you get to see that the minimum and maximum values are now 0 and 1. And so in the right-hand side, in the bottom panel, you're going to be seeing the distribution in the form of a histogram plot. So this will allow you to see the general distribution. All right. And so now we're ready to be building the model. Click on classify. And for
here we are using classification. There is other thing also, clustering, association, select attribute. I think in select attribution they have PCR, those things. In classification we will do what we are going to do. What we
under the
do.
Classifier, click on choose. And then in the functions, find linear regression. And then for cross-validation, number of fold to be 10. So this corresponds to the 10-fold cross-validation. And so
okay. Yeah, what we are going to do is in classification functions, linear regression. We're using linear regression. Okay. Cross validation as a 10 validation. It will split into 10 class and 10 different splits and validate those things.
So in 10-fold cross-validation, you're essentially going to be splitting the data into 10 segments, and then you're going to be using 9 segments in order to build a model. And once you finish building the model, you're going to take the model and then apply it for prediction on the left out segment. And then you're going to be doing the same thing over and over for 10 times so that each of the 10 segment will be left out one time and used as the testing set. Whereas 10 of the iteration will be using different combination of 9 segment in order to build a training model. Okay, so I'll provide you more detail of that in one of the Medium articles that I have written. And so I'm going to be sharing you the link in the video description of this video. All right, and so let's click on the start in order to make the prediction. All right, and now you can see that you have already created a simple linear regression model using the dataset, CPU dataset. And now you have a correlation coefficient of 0.9 and then the root mean squared error of 69.556. And so this is the equation, the multiple linear regression equation of the model that we have built. Okay, and so it's very simple. And if you want to have a prediction model for your training set, you could just click on it. And then you click on start. All right. And then now you see the prediction for the training set. And this is the prediction for the cross-validation set, meaning that you split the data into 10 folds that I have already mentioned. And if you want to do some data split, you could also click on here. And normally we do like an 80-20 split. So I'm going to be using 80. Okay. And then you're going to see the resulting prediction result for your 80-20 split. And more details are here. So you can see here that 80% were used as the training set, whereas the remaining 20% are used as the testing set. All right, so this is fairly simple. And let's say that you want to use a different algorithm. So let's click on the choose. And the multi-layer perceptron is the backpropagation neural network. Let's click on that. Okay, so backpropagation neural network got 0.96 for the prediction. And SMOReg is the support vector machine. Click on that. And you get 0.93. So it should be noted that for the support vector machine, the performance was not so great because we haven't done any form of parameter optimization. So this is using only default values. Let's try other algorithms. Let's see. Trees. Let's try the random forest, which is my favorite. All right. So you can see that random forest got the best performance here without even doing anything as well, using the default.
Can see F coefficient. Here 0.9. And the thing is here we can easily select the function what we want to do and we can apply that one and we can check how how it will perform in those operation. Okay, random forest, random pre, we will okay, I previously also random. We will check random first. 0.9737 like that.
Default values. 0.9737. Okay, and let's try something else. What else? Okay, and this one gave pretty poor results, 0.86. So a series of rules from the prediction. All right, and that's all, right? Let's have a look at the visualize section. So the visualize section will allow you to see the scatter plot of all of your variables. So it's quite small, but you get to see the general distribution of each pair in your variables. Okay, so why don't we try creating our own data set, and then we're going to use it for the prediction. So let me go to the GitHub of Data Professor, and let's download the data on the solubility prediction. So it is Delani solubility. So I'm going to be showing you how you could prepare and input data for your WEKA prediction. All right, so here, let's download this Delani descriptor CSV file, and I'm putting it into the desktop. All right, that's all we need. And then I'm going to open up the Atom, which is a text editor.
Okay, the thing is, for use the dataset in WEKA, we need a different format, and that's why he is editing that CSV, and we will edit according to how we want in WEKA.
I'm going to import the data here. Okay, and now I'm going to save it onto the desktop, and I'm going to be calling it Delani solubility with .arff. ARFF is the input.
ARFF is the file format. I'm going to do that one also. Okay, if you watch that video, you can also get the link. Yeah, main link. Link is missing. There is no link. I will download. Data professor. Okay, I'm going to his GitHub. Yes. Yes, data. Data he downloaded. Delani or something. Delani. FPS CSV. Which one he did download? Delani. Solubility something. Solubility description. I think this one. Okay, I'll download the raw file. Dish. Yeah, man. I think. Isn't it download? Yeah. And also download it to desktop. Okay. What I want to do is now what I want to do is add the Okay, I open the VS Code. Wait, I will show. Okay, VS Code. It will appear. Okay, what we are going to do is the same thing. The learning solubility. Okay, dot ARFF file. Am I correct? Okay, we will check.
File for WEKA. ARFF. ARFF is the input file.
Yes, ARFF. Okay, the input file is okay. Now these are the data. Okay, I want to copy. No, I don't need this. Okay, it's on Vim mode. What I want to do is, yeah, man. Okay, GG. It will go to. I want to select, so I am going to Vim.